Hello guys, welcome back to Introduction to Number Theory. Now we will discuss another Diophantine equation, also very interesting. Let's take a look at this equation. We need to find two powers of 3 and 2 which differ by 1. Well, we all know such numbers. For instance, 3 minus 2 is equal to 1, and also 9 minus 8 is equal to 1. But the question is, are there other solutions of this equation? Let's consider several cases. First case, where y is equal to 1. Well, it's a simple case, because obviously x must also be equal to 1, and it is 3 minus 2 equal to 1. Second case, where y is greater than 1, which means that it is greater or equal than 2, since y is a natural number. In this case, we may notice that 2 to the power of y is divisible by 4. So 3 to the power of x must have remainder 1 when divided by 4. Let's just think for a second. What does this say about x? When is a power of 3 congruent to 1 modulo 4? Well, we understand that it is only in case when x is even. So let's say that x is equal to 2a. This allows us to transform our original equation into a difference of squares and then decompose it in a standard way. And now these two factors, when multiplied, give a power of 2. So we understand that each of them must be a power of 2. And this gives us the next step, where we notice that the difference between these two factors is actually equal to 2. So now 2 powers of 2 differ by 2. When is this possible? We understand that the only way 2 powers of 2 differ by 2 is 4 and 2. So we understand that m must be equal to 2, k must be equal to 1, which gives us y and x. So we understand that the only two solutions of the original equation are 3 minus 2 equal to 1 and 9 minus 8 equal to 1. Now let us consider a more general equation where we take two arbitrary powers of natural numbers, but real powers, which means that n and m, which are upper numbers, need to be greater than 1. And we ask ourselves and ask everybody whether there are such powers of natural numbers which differ by 1. Well, one such pair of powers we already know. It's 9 minus 8 equal to 1. But the question is this a unique solution? Are there any other solutions? This question and this problem was set a long time ago by French mathematician Catalan as a conjecture. So Catalan supposed that there are no other pairs of powers that differ by 1. And for a very long time, nobody could prove this or find a counterexample. Recently, in some sense, Romanian mathematician Mihailescu proved that there are no other pairs of powers other than 9 and 8 that differ by exactly 1. So now we know that this is a unique solution of this Diophantine equation.